Hi, I'm Kane and welcome to another Sen3D video. Today I'm going to show you how to assemble all of the components in the Ender IDEX kit. I'm going to take you through the motherboard, stepper drivers and cabling, assembling the custom IDEX carriage, the remaining kit parts and components, preparing the X-axis aluminium extrusion, and finally some troubleshooting tips. This video is for anyone that's purchased the Ender IDEX file pack and plans to print everything yourself. If you've purchased a full kit from me, you can jump straight to the build video and skip everything I'm going to demonstrate here. As a reminder, you can buy the file pack or the full Ender IDEX kit from enderidex.com. I also supply individual components like the extrusion if you don't have the equipment to drill it, or the carriage parts if you're unable to print ABS. Just visit enderidex.com to find out more. First up, we're going to dive into the motherboard. You can use any board that is able to drive at least 6 stepper motors. That's for X1, X2, the Y-axis, Z-axis, Extruder 1 and Extruder 2. I'd recommend the SKR Pro by Big Tree Tech. I'm using version 1.2 and it's the board that's included in the full Ender IDEX kit. It's also the one I'm going to use in this video. It offers excellent power and versatility and is only really comparable to the duet boards, which cost around 3 or 4 times as much. Let's take the board out of the packet and look at the different ports. Before we start, just make sure these 3 jumpers are in the left position as opposed to the right, just like this. On this left side, we have the main power inputs and outputs. Now, unlike most 3D printer boards, this one breaks input into power for the motors, the board and the bed. You can use the individual cables that come with the motherboard and wire each one into your power supply. However, I'm going to use this custom cable that comes with the IDEX kit. It combines all of the inputs into a single XT60 connector and plugs right into your Ender 3 power supply. Now the power is hooked up, I'm also going to install the output cable for the bed. If we move down to the bottom here, we have 3 hot end heating connections. This board can run 3 hot ends, but for the IDEX we'll just be using the first 2. These are simple screw terminals, and hot ends do not have a positive or negative polarity. Next to this are the 3 fan outputs. Typically these would all be used for print cooling fans. However, we're actually going to use the first one to control the hot end cooling and box fans. This means we have control over when these fans come on and off. With the Ender IDEX firmware, the box and hot end fans only start when one exceeds 50 degrees centigrade. This means unlike the stock Ender 3, when you turn on the Ender IDEX, the only fan you'll hear is from the power supply, and it's much quieter. I'm going to use one of these cables with a short wire and Wago clips to connect the hot end fans and box fan together. For the remaining 2, you just have to install the hot end 1 and hot end 2 parts cooling fans. Remember, positive and negative matters for the fans, and for most the yellow cable is positive. We can now move to this section here. This first row are our thermistors, starting with the bed, hot end 1, hot end 2 and hot end 3. We won't be needing this one. Just above we have the minimum end stops. We have X, Y and Z. Finally, just above that are our maximum end stops. We have X max, Y max and Z max. We'll only need X max on this row for our setup. Thermistors are pretty simple to hook up. They don't have any polarity, so just make sure you plug them into the right slot. You'll also notice that the end stop sockets here have 3 pins, but the cables on your Ender 3 have just 2. Once again, there's a custom cable that can solve this. You can see we take the bottom 2 of the 3 connections and either connect that directly to the existing cable, or you can make a new cable that plugs directly into the switch, where those 2 wires split to either side. The display cable is super simple, it just plugs into EXP1 at the top. Finally, we come to the motor connections. Starting from left to right, we have X1, Y, Z. This here is a socket for a second Z motor. If you wanted to use this, just remove these little red jumpers and plug it in. Next we have E0. This will be extruder 1 for hot end 1. E1, this will be extruder 2 for hot end 2. And finally we have E2, which we'll be using for the new second X-axis motor. Now below each motor socket is a gap we can plug our stepper motor drivers in. A stepper motor driver is a small chip that takes the instructions from the motherboard and converts that into movement on the relevant motor. For the Ender IDEX kit, I use DRV8825 chips. They're excellent value, reliable, and drive the motors noticeably quieter than the stock Ender 3 ones. Although I should clarify that they are not silent stepper drivers, I'll demonstrate those in a minute. To install the chips, we need to remove all of the jumper connections and then reinsert them as shown here. You can now push the stepper drivers into the board. The last thing we need to do is tune the stepper drivers. Stepper motors come in different sizes and can handle varying amounts of current. Providing too much power to a stepper motor will cause it to overheat and reduce its lifespan. Too little power and it will skip steps while it's printing, causing layer shifts. To measure the setting, you'll need a multimeter like this. I'm also going to add a crocodile clip to the positive lead and clamp on this small flathead screwdriver. If I select continuity mode and touch the two, I can hear everything is conducting okay. I'm now going to ensure the motherboard is not resting on anything conductive and plug it into power. You should see some of the lights come on. From this point forward, be very careful. Don't touch the board as there is a high risk of either damaging it or injuring yourself. Now the board is powered up, I'm going to select the 20 volt reading on my multimeter. I'll very carefully touch the negative probe to the ground on the left and start with the first stepper driver. Touch this tiny screw at the top of the driver and you should get a reading on your meter. Now I know the Ender 3 X-axis motor has a rated current of 0.84 amps. So all I need to do is divide this number by 2, which gives me 0.42. I can then take 10% of this as a precaution, so I'm left with a value of 0.38. All I need to do is very slowly and carefully turn that screw until I get a reading on my meter of 0.38 volts. I can then move to the Y-axis. This has the same rating, so I'll tune it to 0.38 volts again. And the same for the Z. The stock Ender 3 extruder has a higher rated current of 1 amp. So 1 divided by 2 gives me 0.5. 10% off of that gives me 0.45 volts as a value. The last two, extruder 2 and X2 values, will need to tune depending on the motors you have or buy. You can normally find the rated current of a motor on the product listing page when you buy it, along with its other specs. Once you're done, turn off the power. You can now peel and stick the heat sinks onto the stepper drivers. They get quite hot while they're running, and these will help dissipate the heat. Before I finish with the motherboard, I'm also going to demonstrate how to install TMC2209 stepper drivers. Now these cost about 5 times as much as the DRV8825s that we just used, but they're what's known as silent stepper drivers. So they can move the stepper motors with almost no noise at all. They have lots of other features and capabilities, but there are plenty of other videos on this subject. For these steppers to work, you need just one jumper for each stepper driver as shown here. If you plan to use sensorless homing, you can just insert them like this. However, if you want to use your mechanical end stop switches for homing, we need to disable this pin here. I'm going to clip mine off, but you could also bend it out of the way so that you can re-enable it later. You can then install the much bigger heat sinks on top. You'll need to upgrade your firmware to recognise the new stepper drivers, and you'll actually be able to tune them in the software itself. We're now ready to look at the custom carriage for Hot End 2. This is a special carriage as it can be raised and lowered by turning this screw here. As a result, you can tune hot end 2 to be at perfectly equal height to hot end 1. This is vital if you plan to do any duplicate or mirror mode printing, where both hot ends touch the bed at the same time. These parts are also printed in ABS. This keeps them super light and gives them excellent heat resistance so close to the hot end. First things first, I'm going to take my carriage base and disassemble it. I can now slide the carriage base over the top. I'll use an M3 by 10mm screw here to lock it in place. Now reinstall the wheels, but this time flip the screws around. This keeps the shallower screw head at the back and avoids collisions. Get the screws nice and tight, but don't overdo it. The wheel should feel secure and run nice and smoothly. Finally, press an M4 by 60mm screw into this pocket here and feed a spring onto that. We can now turn to the hot end mount. I'm going to first install an M4 nut in the centre here. It will be a tight fit, but this ensures almost zero movement as you raise or lower the hot end. Make sure it's all the way in and the screw path through is clear and straight. If it's not all the way in, the mechanism will jam as you raise the hot end. We can now add M3 nuts here, here, and 2 here. Take your hot end and thread 2 M3 by 20mm screws through it. I add nylon washers to the other side as an extra heat break and level of protection. With the mount oriented this way, we can carefully tighten both screws to mount the hot end. Make sure the nuts on the back have threaded onto the screw successfully. As you can see, any other hot end with the same mounting points and of a similar size could also be used here, such as the popular Micro Swiss all-metal hot end. Now slide the mount onto the base and tighten the screw to raise it about halfway. For the fan housing, we're going to mount 2 fans. Inside, we can place a 24V 4010 fan. Clip the cable support and orient it this way with the cable in the top left. Secure it with 3 M3 by 10mm screws. Don't over tighten it as the fan is very light and you're only screwing into ABS. On the outside, we can slide a 24V 4010 blower fan into place and use 4 M2 by 8mm screws to hold it securely. You can now take the fan housing, pull the hot end cables inside and slide it onto the mount. Add an M3 by 10mm screw on the top and an M3 by 8mm screw on the side to secure it into place. Finally, slide the tensioner into place and ensure you have the notch matching the other side of the carriage. Place an M5 nut into the end and screw an M5 by 60mm screw into the other. It just needs to be held in place for now. Take your timing belt, slide it through the fixed side of the carriage with the teeth facing up, add an appropriately sized belt plug and pull it back into place securely. Your carriage is now done. You can also add some cable management like braided cable sleeve if you like, or keep it simple with zip ties. The second X-axis motor is really simple. It should fit snugly into place with the socket facing down. It takes 3 M3 by 8mm screws to hold it. Now slide on the pulley wheel and tighten it so the top is flush with the motor shaft. For the pulley arm, we can install the end stop switch here and secure it with 2 M3 by 5mm screws. Next, slide an M5 nut in the top and on the other side start to screw in an M5 by 20mm screw. As soon as it starts to protrude, slide the idler wheel into place. Now screw it all the way through and into the nut. This is very easy to over tighten and damage the part. It just needs to be secure and hold the wheel in place. There's nothing unusual about the extruder setup. It's almost identical to the stock Ender 3 one. Slide the motor into place with the cable socket facing outwards. Add the plate facing inwards and secure it with the relevant 3 screws. Tighten the extruder wheel at the right height. Add the arm, the spring, this last screw, and the PTFE connector. You can now bring it all together. Take the motherboard box and install another 24 volt 4010 fan with M3 by 10mm screws. Now gently persuade the motherboard into place. Use the USB slots to line it up and gently press it until it clicks into place. You can screw it down with 4 M3 by 6mm screws, one in each corner. Gently manage the cables out of the rear gap. This is also an ideal time to hook everything up and test it's all working. It's much easier to identify an issue while the lid is still off. Once you're happy, turn the power off and slide 6 M3 nuts into these slots along the top. Install the box lid and screw M3 by 8mm screws into place. Again, don't go mad tightening these, you just need to secure the lid. You'll also notice this version of the box has a single mounting track and a flat lid. In my IDEX kit build video, the box has this dipped cutout and matching lid. Both options are available to print or order. The box with the cutout is more slimline and fits underneath the Y-axis of all Ender 3 models. The larger square box requires you to also use these legs to raise the printer height by 25mm. But this does give you more box space and also room around the printer for cabling. They both function identically, and it's a matter of personal preference which one you choose. The last part we need to make is the wider X-axis extrusion. The Ender IDEX extends the X-axis by 55mm on the right side. This gives the new second carriage somewhere to park, enabling Hot End 1 to access the full bed. It also gives the X2 pulley arm somewhere to mount. You'll need a 400mm long piece of 2020 V-slot extrusion. You can also download and print these drilling guides to assist you. They have small guides to drill 3mm holes that can be tapped with an M4 bit afterwards. They also have these larger holes with inserts. Use this insert to drill the 4.5mm hole all the way through. Then swap it out to drill the 12mm inlay on one side of the extrusion. This creates a gap for the screw heads to sit flush. Measuring from the left, the 4 smaller holes are at 3, 29, 257 and 336mm. The larger holes are at 49 and 279mm. This part is probably the most challenging to build, especially if you don't have tools like a drill press. Don't forget you can buy just this part from enderidex.com if you wanted. Once you have your extrusion cut and drilled, you've got everything you need and you're ready to start the build. As a final bonus for this video, I'm also going to go through my process for troubleshooting and solving problems. In this example, I've set up my printer and my Y-axis is not homing. When I run an auto home, the bed doesn't move, but I can still move the Y-axis via the screen. This would seem to be an issue with the end stop switch. The first thing I want to do is identify everything in the chain that could cause the Y end stop to not work. We have the end stop switch, the cable, the adapter cable, the motherboard, and the firmware. This covers end-to-end everything that could be causing the issue. If I replaced all of these components, I'd essentially have a completely different printer. Let's start with the switch. I'm going to take the cable from the X-axis switch and plug it into the Y-axis switch. Now if I turn the printer on and auto home it, I can trigger the X end stop with my finger. As you can see, the X-axis home's okay, so I know the switch is working. We can cross that off. Next, let's test the cable. I'm going to return the X and Y cables back to the correct switches, and this time I'm going to unplug the Y end stop cable from its adapter. Now I can plug that into the X-axis adapter, so I have the Y-axis cable and switch connected to the X end stop. Once again, I'll boot up the printer and auto home it, using my hand to trigger the switch. It works, so I can rule out the cable. As before, I'm going to return everything back to its correct sockets. This time I'm working my way up the chain and testing the adapter cable I made. Looking at the motherboard, I can unplug the Y end stop cable and plug it into the socket for the X end stop. So now the Y switch, cable and adapter are all plugged into the X end stop socket. This time when I try to home the X axis it fails. So now I know the issue is with my adapter cable. If we examine the Y cable next to the X cable that we know is working, you can see that I've accidentally mixed up the wires. After fixing this, I can plug everything back in and it's all working again. The principle which is so important is to list all of the potential causes you can think of and systematically test them one by one. You need to be patient and test one thing at a time. Too often I speak to people that had a problem and made 5 changes at once. Rather than solving the original issue, they've tied themselves in knots and caused multiple new problems at the same time. Take your time, lay it out and be systematic in your approach. I promise you'll find the cause and solution a lot faster with a lot less stress this way. And of course, if you can't solve your problem, I'm always available and happy to help. If you're ready to start assembling your kit, you can watch my build video via the link in the description below. You can also learn more about the kit, parts and files by visiting enteridex.com. Let me know what other videos you'd like to see in the comments below. Perhaps how to install BL Touch on an IDEX machine, or maybe compiling custom IDEX firmware and settings. Don't forget to like this video and subscribe, it really does help me out, and until next time, happy printing.